Okay, we should slowly. Is it yours, Bunji? We will start slowly coming back to the workshop. Raise your hand if you hear me and you see my screen. So this should be an easy task. Uh, okay. Okay, I hope at least somebody's following. Then before we will go into the C#, so we will stick in the with the Grasshopper for a few minutes more, because I want to explain you a dispatch function, which will be a soft introduction to the dealing with the scripting. Give me just a second. I need to clean, and then yeah. So what I make here is some small description. So again, we are starting here. We have 24 geometrical objects, which are 24 closed B-reps. Each one of this B-rep, it's listed, so it has the index number, and then you have the item inside. What I have been doing here is I was deconstructing it, finding the central point of it, or centroid, the position of the center of the surface or a face of the B-rep. I was changing it into the point, and then I was projecting in on the one common ground. Now I was calling the duplicates. I have a list of 24 points which are on the level of XY plane, and I have also a list of 24 B-reps. So I have a list of 24 B-reps. I have a list of 24 points. Now I would like to find those points in this list which are having X and Y in some kind of the range. So for example, let's say that the X coordinate of those points should be between 2 and 6 meters, and I would like to take them and highlight them in the field. So I will take those basic point columns, and I would like to create the if statement if this basic point column X coordinate is between 2 and 6 meters. So I will deconstruct it. So I will delete this part. I will type XYZ, and I will find deconstruct a point into its component parts. I will take this one, connect it here, and now I will have the list of X and Y's, and I would like to check if this X is smaller than something. So I will introduce smaller than. I will click enter. So this is kind of the important to find. It's like smaller or bigger. You choose smaller, and I connect with this. You will find those operation in the oh yeah, you don't see raise the hand. It's not working anymore. It's at least I can have it here, raise hand here. So please raise your hand if you know if you know how to raise your hand for the people who are following. So in your teams, you should have this raise hand. It's not working. Oh. No, I don't see you. Okay. So we don't know why it's not working, but I believe you, all of you are following. Yeah. So I just have faith in you that all of you are are still on the board. Um, so I hope I will just continue. So we are creating smaller than, um, and we will figure it out why it's not working later. In the maps, you have all these basic options, so smaller than, larger than, so we can drag it from this ribbon. You can just search for it, and it will be kind of the clever, so you should stay focused now on the screen. So if you have construct x smaller than, and we have to introduce a second number to which we are comparing. So for example, if I want to, I will make a slider from 2 to 4 or to 12 to be a little bit bigger to catch some other points because yeah. So smaller than will produce me a pattern list. Do you remember when we were calling nth item of the list? We were introducing the list of true and falses. So here you have a smaller, if it's smaller than, it doesn't give me back the value. It give me just the information. True, it is smaller, or false, it is not smaller. So this is a trick. And now what we have to do is to use a dispatch um, thing. Dispatch. So Control Shift, it is in the sets dispatch, and this will be probably basic operation in Grasshopper for most of you, because it's speeding the work which you're doing a lot. So now, if I would like to have this value, not the true or false, I need to have a list and dispatch pattern. So my dispatch pattern are those true or falses. I will combine it to this dispatch pattern, and I will see what will be the outcome for the list A. And this list A are just the numbers which were smaller than 2. If I will just drag it more, I see that if it's smaller than 12, it's find 4 extra numbers, which is 7.8. It's also changing here. If I go for 12, remember that you can have a different numbers here. So if you were but I hope you were using my file. But please make it. You have the list here, so you can see that the biggest is 39. So I can make a slider from 0 to. And then if I will go for the last one, oh, I think it's there even a bigger number. So I can make it from 0 to 100 even. So 0, there is only falses. There is nothing which have the x coordinate smaller than 0. If I will go to 100, all of them are trues. But we operate on this with the x coordinate, comparing this. Comparing this to the number, and then this dispatch is working with the list of numbers, but I would like to have the points. I will now turn off the visibility of the whole algorithm. I will just leave dispatch, and I will put here data. Do you know when I was, do you remember that I was explaining that we have a different hierarchy of the objects, and data is the most general one. It can handle numbers, but it can handle also the geometry. So if I will put here now the points, it should be able to preview it. So I will now shift. Here I have an X component. I will change it with my basic point of columns. So I will take all of the points and drag it here. And right now, since it's 100, it's not working. But when I will come into the level of X coordinates, I will see that my points are showing or disappearing, corresponding to the, yeah, it's depending how you call it. So we have something which is reacting with the changing variable. What is here important? That we used some object which is inherited or it's taken from some set of objects. We deconstruct it. We use the x coordinate. We compare it, and then we said we have a true and false, true or false information or the list. This list length, it's exactly the same as the number of points. So here we have 24 points, and here we obviously have 24 true or falses, because we have also 24 x variables coordinates. If we would like to now create yeah, one thing. If what is list A and list B, just to make explanation of how this patch is working. So if you take a look here, you have a list of points, point 1, 2, 3, 4, 5, 6, and the information about false, true, false, true, false, true, false. Then it is like taking this information. If you want to, if you are using dispatch, then he is making like a plus here, and if it's false, p1 it's false, it's taking it to the list B. So here I will write B. If p2 is true, it will be A. If p3 it's false, it's B. If p4 it's false, it's again P, B, A, B. And this is exactly the same here. So here you have a B, A, B, B, A, B. So it's like mapping this list over this this set of points. And thanks to this, we have now as a result two lists. One is the list which was created from combining true values on the list, and second it's with the all falses. So if you want to check what is in the list B, it's generally the elements which are bigger than 23. So it's a super fast way to search over your data, because as you can imagine, you can search over most of the data, like for example a volume. If you want to change, if you want to search for the elements we have a specific volume, it's the way how to do it, at least in the Grasshopper. So this patch is very useful, and what we will do now, we will try to use a curve and those points to see which points are in this curve. And this will be the last operation which we'll do in Grasshopper. So we have a curve which we created in Rhino. Those of you who take my Grasshopper file but don't have this curve, you have to do it manually, because I didn't give you my Rhino file. So again, I am drawing a rectangle, right click on the curve, set one curve, and I am setting. So set one curve, and I have a curve here. If it's turned on, it should turn with the green color. Okay, so we have the curve. We want to test if this point is inside our curve. We have an operation for doing it, or point in curve. So in the curve ribbon, go for the point in curve. I will highlight where is this point in curve. Control Alt plus left mouse button will also make you strict with highlighting. So curve, point, I am taking a list. So what I will have as an outcome, let's check. Oh, this time we don't have information true or false. And what does it mean? That we will not be able to so quickly check and if it's inside or outside. Why we don't have it? Because per definition, and this is a good moment to introduce something which is called Rhino Common. All of you should now type Rhino app AP in your Google browser and go for the Rhino Common AP Rhino Developer Docs. We have it in Mural, so if you are also if you let me check. If you want to use our Mural to lead you to this Rhino Common, it should be this one. So developer Rhino 3D Com AP. And this will lead you to the whole database or library of the objects which we can use inside the Rhino and Grasshopper. And since we were using intersection between the curve and point, or maybe not even intersection, but relationship, then let's take a look what Rhino API has us to offer. There is a search here, but to be honest, Google search is working a little bit better. So if you type Rhino API and then curve point, for example, curve contains method. So I will take this one. I know that right now, just follow me. We will, you will get used to Rhino API, especially if you want to do something in the C# and in generally scripting. Even if you are using Python, it's also the way how you should deal with the library of objects in the Grasshopper. And here we see that generally we can use something which is testing if the curve contains a point. And outcome of it, it's here, return value, it's a point containment. If I will click over this one, you will see that 0, it's unset, 1, it's inside, 2, it's outside, 3, it's coincident. So Rhino Grasshopper, it's not giving us only the information if it's inside or outside, but it's giving us also two different objects that it cannot find the relationship. For example, they are on different Z level, or they are coincident, so the point is lying on the line. So if you go for the relationship and hold a little bit, here is saying that 0 it's outside, 1 is coincident, and 2 it's inside. Meaning that we need to, because we want to use dispatch, so we need to implement some kind of the if statement. If something is 0, then it should be true. If something is 2, then if it's inside, then it should be maybe true. And if it's outside or coincident, then it should be false. So let's make this one. I want to take this list and change it into true or false. I will make a equality equality sign, and I will here make a slider 0, 1, 2. I will take relationship to the first number, 0 to the second number, and I will take a look what I have just created. So if it's 0, let's go for the relationship to read. 0, it's outside. So this means if it's 0, then it's true. And you see that the no, it's this 0, it's true. This 0, it's true. 5 is true. We would like to have trues if it's inside. So I will go for the 2. Now, if this 2 is 2, then it's true. If any other number you have, it's false. So I have my cool pattern, which I can combine to my dispatch. I will take this equality list of true or false to my dispatch object. Let's take a look. True or false. Sorry, of course, I make a small mistake. I connect the equality it should be to the dispatch pattern, and this should be to the points. So now I have, so again, this equality true or false should be to the dispatch pattern. List should be just a list of points. So let it, I will highlight all of them, and I will create a sphere on those which are inside of my uh, um, curve. And here we have, we will be able to combine Rhino operations with the Grasshopper operation. Because right now, if I will extrude my curve in Rhino, it will also affect on the elements here. So I will just make those. There is something which is called preview. It's not maybe very important, but nice to know. If you want to preview some of the objects with a specific color, you type custom preview. And you can generally, sorry for that, preview. Okay, so now you see that when I am changing the Rhino objects, it's automatically reacting with my Grasshopper. So since this is taking the geometry from here, from the Rhino, this component, it's like taking it directly from Rhino. Whenever I am changing it, it's updating the Grasshopper model. So let's make break for 5 minutes if you have any question to this part, and after this 5 minutes or maybe 8 minutes, to make it clear, from 1 o'clock we will start C#. So yeah, data conversion failed because you cannot create. It has to be a point. Probably in the dispatch pattern, you are still taking X components here. Take just the basic points of column to the dispatch pattern. It should be done that you have points here, because I see that from your data that you have here just one value. Yeah. As you can see, I was also like changing the curve input to the NURBS curve, which is closed. It's also reacting. So the dispatch, it's really a clever thing. And try also, for those of you who are still playing with it, try to connect the brep columns to the dispatch. How do we change the color of material? I was using this material box, so I just type color. Picker, I think it's called. Swatches. Color swatch, also it's a good one. Yeah, that's maybe even easier one. So color swatch, and here you can just specify. Here is first slider in which you are changing the let's check, and you can also set the transparency. So how is it? Or maybe I will do it with the Europe floors. So custom preview, this one I have to turn off. And here I will just okay. Seems now like it is working. So either color swatch, either the color picker. Color picker, I don't like it so much, but you can also try to use this one. Okay, it's 1 o'clock. We should start with the C#. It's yeah, I will open a new file. This I will save. I will open a new document. I will clean my Rhino, and we can generally start. I will just save it as a day 2, part 2. And now I will work only in Grasshopper. So all screens should be a Grasshopper. And the most important thing, I will type C#. So C# script, clicking enter. Now I would like all of you to raise the hand, but we still didn't figure it out why it's not working. So I just hope everybody have it. If you zoom in and zoom out, you see that generally you have plus, minus on the left and right side. Right side are the outputs, left side are the inputs of your code. And let's make the most primitive algorithm which we can have, which will be taking an input and describing it as an output. So double left clicking on the where it is written C# script will open script editor. So double left click or right mouse button and edit source. So if you prefer to do it like this, right click, edit source. Few sentences here, or no, first we will do the code. Here in this white line, on the gray you cannot write anything, you can try, but it will not change. In the central line, you will write a equal to x, semicolon. I will zoom to this code, which is extremely complicated. Because you have to understand that we are using capital letter A, which is here, equal to X, which is here. So, and then the most important thing in the C#, especially if you are using a different programming language, every line has to finish with the semicolon. If you don't have this one, it will make your code impossible to run. So this is all what we need. I will click now OK, and it's gray, so we have some code inside. And now I will make 2 panels, one as the outcome to test what is going out. Now it's nothing, null. And now we make a panel on the beginning, and we will write first code. So the code, how it is looking. It is looking like this: a equal to x. Capital letters. This is important. If it distinguish between small and big ones, so you have to be aware of that. Try to be consistent and to not. If you would write a, it will be an error. This error you can read here or here. A does not exist in the current context, line 57. I go inside, I see line 57, it's here. Here we have a problem with the small a letter. It doesn't exist. Okay, so it doesn't exist, so we should use something which exists, which is a capital letter A. Okay, right now let's try to make something more difficult. Let's try to make a component which will be adding two numbers to each other. For example, x plus y equal to a. Let's try to do it. A equal to x plus y. I will make two inputs, Control C, Control V. I would like, he is turning red, he's angry on me because he is not able to make plus for the type of the object. And here the second, the most important stuff after the semicolon is to always declare properly your input types. So to make it, I will have to change this object into double or integer, something which is correlated with number to make an operation of plus. To change it, unfortunately, in the script editor in Grasshopper, I cannot do it. Even if I would try, I am now clicking on my keyboard, I cannot do it. I have to go outside, zoom into my input, right click on mouse on it, and here we have a type hint. And now all of you should focus and find it, because this is the most typical error which you will get in the next couple of hours, that you didn't declare properly the type. I will change it to the double, which is a floating number, so it's a decimal number. So I will choose double. I will choose double for the x right now. I'm going inside and I see x is declared as a double. I have still a problem with the y because it's still an object. I will change then the y, right click on the input, type hint and double. So exactly the same what I was doing for x, I am doing for y. So this is super important, because if something is not working, then it's probably this thing. Now I will go inside, double x, double y, everything has changed. So always check here in the script editor if you set it properly. Of course, the reason why it's not working is that because the sorry, I have to talk with somebody on the link. Yeah, I'm back. Sorry, we have some construction site on our corridor. Somebody was drilling. The building is standing, so we are safe. But yeah, let's continue. The problem is that double it is, but we have a string here, so we just have to change it to the number. I will set it as 1 and here as a 2. And my code is running. Now it doesn't have any errors, which is coming from out. I will go for the A as 3, which is equal to 3. So the code is running. Let's change the panel to a slider and see if it's parametric. So let's make a slider from 0 to 10. And now let's shift it. So it seems like everything is running well. I hope for all of you it is running. If for some of you this code is not running, please make a comment right now. we will help you because this is like a starting point for the next thing, which will be a little bit more difficult. But something I didn't get past the a equal to x without error. The letter big or small, did you try it? Because remember it's sensitive on the size of the letter. It has to be small x. So be sure and that you have a semicolon at the end. Yeah, we have a print screen. Let's take a look. Yeah, this is sensitive for the big and XY. So you made it like big with the shift X and with the Y, big Y. Change it to the small y and small x, and it will run like hell. So just let me know if it helps. I will double check if you, yeah, but you set the type hints properly. So I will just see it here. It's double double. So the only, you have to use exactly the same as here. So you can also like make Control C and Control V to be sure that this is exactly the same. Okay. So the code is running, it's sensitive on the letters. How to add a new input? Just plus here and you will have a new input. How to change the name of the input? Right click on it and change this X to, for example, first number. This is this Y will be second number. And inside, I will just delete the Z for a second. Inside right now X and Y, it's not working anymore. I have to take this one here. So I'm using like Control C, Control V to place it to place it, and now my code is running. So name your input correctly on the beginning, because later it will be a lot of changes if you want to change them differently. At least in this, when you are using in the C# in Visual Studio, it will made it. You can make it automatically, at least with some range of the change. So we have first number, the second number, we have output, which is working. Let's make it for the third number to make it clear how it is working. So zoom in, find the small plus here, click on it, write the third number. Hmm? Do you see? Yeah, yeah. The sphere is asking if I am sharing my screen. I hope you see my screen. If no, then somebody should write it down in the comments. But I think it's just sphere who don't catch it. Yeah. Okay, a third number, right click, the same type hint. Here we have to we have to change the type. So remember, whenever you are adding a new variable, we have to add the type. So third number plus Control V, third number. So it seems like we just run our first component. Impressive, impressive. Pretty. Let's leave it like it is and let's start a new one. So this is already a finished job. It can be used in any kind of the project. Let's run a new one. Let's go for the C# script. And then I unfortunately will delete all of the inputs and I will leave just the output. I will go for the panel to see what is outside, and also when there will be some errors, and there are very often some errors, I will be able to read it out of the out thing. I'm going inside. And let's code. Let's say that a equal to 1. And without going outside, I will click on this run script. So I don't have to click OK and go outside anytime I'm changing. So if I will change it to 2 and run here, it will automatically rerun the script and the code and the variables. So now I need to say something about the type of the objects. We already know that there is a double. We know integer. We know, but let's take a look. We have integer, which is generally 0, 1, 2, 3, 4, and stuff like that. So integer, let's call it E1 equal to 0. Let's take double D1 equal to 0. So when you are writing, you see that some of the sentences are turning automatically into the color, a blue color, or I'm not specialist in colors, but this is probably a blue. The rest of it, it's black. Those which are turning into the color, especially blue, it means that they are meaning something in the C sharp. So we should not use it. For example, if I would like to use the integer, so ent, for example, means that this object is of a type integer. It's a forbidden word to use. So this name is the name of the variable E1 equal to 0. So E1 right now it's the variable. I can do many things with E1. For example, changed it, or I can take it as an output. Let's test it. It's turning green. Sorry, not green. Orange. We don't care. Orange. It's still a good color. Still, it's running the code. This is a warning. Red color we don't like because this is an error and it means that the code didn't run, didn't succeed. Orange, it means just that something was not perfect, but we will live with that. So he's saying that variable d1 is assigned, but its value is never used. That's completely fine. I will use it later. Let's just take a look what we can do with e1 variable. So right now, if I will take a new line, remember to place semicolon. Again, this is the most important thing. Semicolon at the end of every line of the code. Um, I am clicking enter. Also, one thing, the debugger is going from the left to the right, from the top till the bottom. So whenever you are putting the information, remember to first declare your variable and then operate on it. So when I will right now type e1 equal to 1, so I will overwrite the variable e1, which was previously 0. Now it's 1. And I will run the script. It changed the the um, the item inside of the variable. I cannot do opposite. I cannot first say e1 equal to 1 and then say e1 is of integer 0. This will make it red, and we don't like this color in this during creating a code. So I will come back to the first position, integer e1 equal to 0, e1 equal to 1. What will happen if I will use as an outcome d1? I will run the script. Again, it's turning orange because e1 it's declared but never used. We didn't use it to as an outcome. So let's try to do it. If I zoom in to my outputs, I will click plus and we'll have B. And unfortunately, you see that reference object is A. In this case, if we are adding inputs or outputs, we have to close script editor window and come to it again. So I unfortunately have to go inside again. And this time I have the reference object B. And now I will say that A is equal to D1, but B is equal to E1. Okay, it's gray, so it's great for us. No warning, no errors. We have two outputs which are running. So we have we know two types. Double, it's 0. Integer E1, it's 0. Let's delete for a second this E1 equal to 0, and let's change E1 to 0.1. I will rerun the script by clicking a red arrow, and unfortunately he is saying that integers cannot be with decimals. Let's try this with double and see if it's working. Yeah, it's working perfectly. So unfortunately, like with every programming language, we have to declare our types correctly to use them correctly. If I will go now, we know two numbers types, so integer and doubles. We know what is the difference now. Let's try to implement a text. The text is called string in C#. So string, you see it's turning blue. It means that it's forbidden word or it is already declared in C#. I will call string S1 and placed here a text. To place the text, we need to use apostrophes. And here we can say text is very important. And let's make another output. So all of you should know how to do it. See, zoom in. One, running. Let's take a look. And we have our text. Okay, so now if I will change, I would like to change S1 to different thing. For example, text is not so important. I can run it and it changed. So we have three basic data types already explained. So we are almost at the end of of the basic explanation how the C# is working. We just need to introduce the lists and some statements and conditions. So let's come to the first thing, which will be maybe the list. Or sorry, before we do that, we will go and try to declare an object from the Grasshopper. So for example, point 3D or something like this. Why I said point 3D? It's yeah, I should how I know how to declare the geometry. It's everything is again in the Rhino API. So if I will take Rhino API point, he is saying Rhino develop. He's finding as the first one point class Rhino developer docs, and here we have a point 3D. We have here a point constructor and so on. But unfortunately, you have to know that this is not exactly a point which I would like to use. I would like to find the I would like to find point 3D. And unfortunately, this is something which you have to just know a priori when you are starting it. So let me check point 3D. Yeah, and here we have a different type of the constructors. So we can take a look on this one. Point 3D in the brackets, open brackets, double X, double Y, double Z. This will give us point 3D. So right now I will come back to the script. I will click OK. I will take it on the site and I will create a new C# script. This time I would like to also delete all the inputs, but I would like to change the name of the output to the PT or my point. No matter what you will do, it's not so important how you call it. The most important thing is to be consistent. So if you have my point, then my point can be declared as any kind of the object. I will just take a look on the panel to see if it's working. So I will run it and I have it. Okay, so remember, no, I call it my point, but this is not a point. This is just an object. So it can be anything. So I need to make it a point 3D. I know from Rhino API that the form in which they want to create a point or the data type looks like this. Point 3D, I will now write the name of it. For example, P equal to the new point 3D. And here he is waiting for 3 doubles. Right now you see he is giving us a tip. So we have a small gray ribbon, which is showing point 3D can be constructed from double X, double Y, and double Z. So let's make it. Let's make 3 doubles with the value of 0. And let's take this my point as this P which we just created. So we see our point and it will be also visible in Rhino right now. So we first right now create the, oh, it is here. So this point, it's this point. It's kind of the amazing how fast we are in progressing. Now, my point, it's P. This P has got a series of properties and series of features which we can change. So if we come for the point 3D in the developer Rhino API, if we go for the point 3D structure, we generally see constructors. So this explaining how we can create it. So a priori, we can create a point out of the vector. It's kind of easy because both of them has just 3 properties X, Y, Z. And we have also properties which cannot be or they have to be in every object, and we have a methods. Kind of the easy to understand the properties are because X, Y, Z are just the X, Y, Z coordinates. Also, if we go for the methods, some of them are easier or better explained, but let's start from properties. We know how to use the constructor. We create a point. Let's try to get the information out of it. So I will go now for the point, and right now I would like to create 3 outputs. Each one of them I will call X, Y, and Z. This graph thing, it's by coincidence. I will, sorry, it should be like this. So right now, if I'm going here, sorry. I have X, Y, Z, and they are also here. Let's make them work or showing something. So small x, it's a reference object. So it is the outcome of our script. I will type P, so the name of my item, put a dot, and automatically the library of the properties and methods should appear. Here I can just move my key down and up keys on the keyboard, either I will know it from a Rhino API that the capital letter X, it's the X coordinate of my point. Y, I can get by typing capital Y, and Z, it's equal to the P point Z. So I will run it, go over it. So X is 0, Y is 0, Z is 0. Now if I will put some numbers here, some random numbers, and run this script, I should have the variables which are corresponding to it. So now I know how to construct a geometry object, at least the point 3D at the moment. I know how to read the data from it. It's called reading properties or operating on the properties. And I know generally, or no, I don't know methods at the moment, but we will know it soon. If we would like to create a second point, there's let's change its name, and here it's one thing. If you call it P and I will now put P1, those P doesn't know what to do now because we didn't declare it before. So if I would run the script like it is right now, he will make it red. So I have to take here P1, 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 and now I am able to create a second point. I will just copy it to not repeat unnecessary thing. So I have 2 points P1, and the second one I will change to the P2. I will run this, and here I see also I have to use P1. Okay, my point, but P2, it's not going outside of my code. I will just create a little bit different outcome. So I will produce X as a 10, an input for the P2 point. And now I will create a line. Line, my line, new line. And here he should help you. Point from, let it be P1, and point to, let it be P2. You have to get used to this script syntax. So first you are declaring the type, then the name, then keyword new, because this is the first time you are declaring this item. Again, the type of the object, and then you are using a constructor, P1, P2. Okay, let's change or let's visualize this line. So I will go and change X to my point 2, and Y I will change to my line. My point it's P1, my point 2 it's P2, my line is equal to my line, but written from the small letter. So remember, although it's looking almost the same, the capital and the small letters are making the difference. I will just delete this part. Also the Z will be not used, but let it be. I will click OK, and I should have the line. Okay, so I have it. So the last thing which we will do, I would like to, I think all of you also would like to create my list to make it quite, and then we will make a break. So 10 minutes more and 15 minutes of break. My list, the outcome, and now how we are declaring a list. Kind of the complicated on the beginning. We have to write a keyword list, then the triangular brackets, and then you have to declare the type of the objects which will be inside my list. I will go for the integers on the beginning. So I would like just a list with the integers, and I will call this list a list with axis. And then I have to type again NU because this is the first time I am declaring this variable. Triangular brackets, integer, and important thing here, empty constructor, which means empty circular brackets. So this is how we are declaring a list. Complicated? Yes. Is it long to declare? Yes, but Visual Studio will help us with this. And if not Visual Studio, then the shortcut for it would be to write var, which is a variable, list with wise, new list integer. So since variable it's very generic object, it will just automatically get the type from the description after the equal sign. We can also do it with the points. So if I will type var p2 and then equal to new point 3d, it will also work. So we have two lists. If I would like to make a comment now in our script syntax script editor, I have to make two backslashes and then I am writing a comment. So sorry, no, you don't have to write comment. You now everything what you wrote will be a comment. So this is how you can create this. This is how you can do it faster. This part, unfortunately, you are not able to change. You see the comments should turn into green. If they are turning green, it means that the debugger will not read it and will not execute this code. So yeah, this is first thing. Now what we can do with the list. First of all, we have to take it. Okay, we have my list, and I will just type outputs. This is just a comment to clean my code. And here I will type my list equal to I will just copy it to net. Mistake. So my list will be equal to list with access. And let's take this super long name and put a dot at the end of it. To add something to the list, we need to use a keyword add. So dot after the list with access, capital A, D, D, empty brackets, semicolon. Remember, semicolon at the end of every line. And now we are just putting here an integer. So 1. I will just copy it and paste it here. For example, 4 times. And I will say 1, 2, 3, and 23, like Michael Jordan. So we have 1, 2, 3, and 23. Let's click OK, and let's check if we have this my list. Oh, it's working. So we can have a break. Since we have a break, and after the break we will implement for and if statement. All of you should train in this break how to make lists and how to operate on it. Maybe one, no, we will figure it out later. So if you have any question, you want me to repeat something, waiting for the comments. Okay, we are back in business. One of you asked about the CSV file, so I just showed a quick method. I hope mm, uh, it's not difficult. You just have to read file, have a read file component, and then you need a file. So to have a file, you are using something which is called file path, and you can generally take any kind of the file. But of course, the CSV or TXT format, it will be possible to read. Later tomorrow, also, I think Bunji will show you how to read this file from the C#. So make it directly from C#. But before we go into this one, we need to be better in generally creating our own lists. Okay, so this is one thing. I will just turn it off. This is something. I don't know if Sfera explained you this one, but you can disable the code and you can disable preview. If you will disable preview, it means that you generally don't want to show it, but it's still running in the background. If you are clicking on the disable, this means that generally it is not working at all. One nice thing is to disable a solver, especially if you have a big models. Sometimes it's quite efficient to start your work with this lock here. If you did it by mistake and you see this lock, it means that no code will be running, although you can make a code, calculate some area or make some brep. You see I can connect them, but all of these connections will be orange because there will be no data because the solver is blocked. So now I will enable solver and it will turn orange. So this is quite useful, especially with big codes which take some time to run. Then to when you are starting the opening the new file to disable the solver. But our files will be quite simple and light, so you can take it as granted to have the solver running. In the mural on the right top, I will place all the codes which we were using today. So you will be able to just Control-C, Control-V this one and paste it. Okay, let's go for a new C# component, this time with the first for loop. So it will be amazing. Let's go for the C#. And one thing what we want to do, we want to create something like a series, but built by ourselves. So let's make count exactly like it is in the series. Type hint integer. I will wait a second until all of you will set it as integer. Right click and integer. So here you should have integer and count. The second one will be not used right now. I will just delete it. And the only thing which I want to do is to create a list from 0 with a specific number, which is declared by the count. So I will make a slider from 3 to 40, for example. And now A should be series. I just call it series. I can call it completely different. I can call it my series to not make you think that the name of this it's meaning something corresponding to the series which is here. So this is the one from the ribbon. This is made by ourselves. We'll try to make it in the C#. So I go into C# code. Here one more time, check if count is with the integer type. If it is, perfect. If not, go out and make it as to be as an integer. Let's make the statement or the first code. I will go like this, outputs in the comment, and type here inputs or variables, the comment. So I will clean my code a little bit, and under the variables comment, I will write down list of type, let it be integer right now. I will call it series equal to new list integer and empty brackets. So this is script syntax. I cannot say anything more about this that I said. This is a type. This is a type. Here we have a constructor, empty brackets. Remember, here is empty, and semicolon at the end, the most important thing in the C#. Okay, so we have a list which we would like to make with the numbers. So the outputs, my series equal to series. I will run it. I will connect the panel here. So it'll be one of the long one at the end of running my code. Then voila. Okay. Let's run like this. Series dot add. Run it. It's working. So now the only thing which we need is the loop. The loop which will be running till for the number of the which is declared in the integer count, and it will implement add and elements to the series. So let's make a loop for empty brackets. Inside we need to create an instruction int, so integer I equal to 0 semicolon I smaller than 10 I equal to I plus 1. So integer I equal to 0 is the starting condition. If do the operation until I is smaller than 10, if and in each operation add plus 1 to I. It's kind of the simple. But where we are placing the for loop, the for loop have to be placed in capital brackets after the for statement. So the loop is making it is made here. So I will run it, and I see that nothing is changing right now. What I will do, I will place this series up to this between these capital brackets. I will run it now, and I will have 10 zeros in my list. Okay, so the loop is almost working because almost it doesn't correspond to my to my count number. Where we should place it? Of course, we should place it instead of this 10. This is why the count should be of the variable integer, because if it will be a double, it will not be able to compare integer with the double. So I will place here count and run the code. So now I see that I'm producing a series with this, or the list with the specific length. Let's now, instead of adding 0, placed here I. I will run it. And what is it doing? It is in every in every operation in the loop, adding +1. What will happen if I will do this is I equal to I plus 1. It's a command which is done with every iteration. The shortcut for doing it, or it can be also I plus 2. It will also be working. So 0, 2, 4, 6, until it's not bigger than 7, it will create the list. I will stay here with 1, and also I will create a shortcut, or famous shortcut is I plus plus. It is not also only in the C# language, it's in many languages. It means that I want to add +1 with every iteration. But remember, I plus plus is equal to I equal to I plus 1. Okay, I will take this code. I will place it in Mural. So if some of you wants to sorry. If some of you wants to take it, just take it. If you have some bugs or something, you can also ask about it. Now I have my code running. It is producing, but the classic series, which we got from the, has also a start and a step. So let's try to make this. Let's add an input, which will be start. And this time it will be a double. Type hint. Oh, sorry, it opened on the different window. Double. And what was there was a step. And it will also be again, it will be also be a double. Okay, so we have a C# script, account, start, and step. How to make a start? Let's place here 0.4 start, and the step should also be 0.5, for example. I have to get out of the C# script syntax, and I have to reopen it because I want to have two new inputs, which is start and step. Okay, I have start, I have step. Now what we will do, it's first of all, we have to think how we want to create our series. So since we want to start from the start, let's and also one thing, the easiest way to doing it would be just to say integer I equal to start e plus step, but start and step can be a double, so we cannot do it like this. Unfortunately, we have to use some different method because we cannot make a for loop over the doubles. We have to do it over the integers. To make it, we have to, for example, use I or convert I inside the inside the the loop, for loop. So we will say double, and this will be for example, ID. And here we have to use something which will be converting integer into the double. How to do it? I will tell you, if you don't remember that, it's the easiest way is to ask Google. So to change the double to integer, you just type C# um, integer to double. And since here we are not touching anything from the Grasshopper or Rhino, we generally, since C# is written by Microsoft, most of the objects you will have here. So you see the namespace, it's system, assembly system runtime DLL. Here you have two double and you can place the integer inside and you will have a double. On the beginning of our code, if we click on this small plus here, we see that we are using a system library. So this is exactly the same library which Microsoft is talking about. So right now, if I am typing system dot, we should have something which will be running on the collections and it will be enabling us to make a conversion. Let's take the look on the convert. So system convert to double. Let's use this one. I will just system ID convert to double and I. So what has just happened? I have been using a library of the using system. Since it's already here added, I can use it directly. So write convert dot to double I. It's per definition in the C# that you are able you are able to transverse integer into double. So right now this I, which is 0, 1, 2, 3, 4, 5, 6, it's not longer integer here. Or I, it's still integer, but we are taking this integer and declaring as a double ID. So right now what I can do is I can say that I will take start, I will add step, multiply by ID. I will run it and I will have a small error, which is of course because I didn't change the list type. Per definition is integers. I forget about it, and since we want to have doubles there, so we have to write double here instead of integer. I will run it and I will have it. So okay, so we use the system library from the Microsoft to convert the integer to double. We create a series which is generally a code which is creating a series. I will just copy this to the mural to all of you to be able to use it. So I am copying always with the inputs here. So remember when you want to copy it in your code, just take this one between the brackets. Don't take this one also, because this is something which you have to declare by yourself. But I want it to be here because then you are able to see what kind of the inputs I was using. So yeah. Okay, I will click OK. This code it's working. Let's see series start step count. Maybe we have a little bit different order of them, but other things should be working generally the same. So like you see, if I will make one, I generally am producing the same outcome from these two. So Let's make it really big, from 1000 to 200,000. And here, one thing. Generally, in the display, you can turn on something which is called profiler, and this will enable you to see how fast your component is. If I will turn it off, it will disappear, but if I will have it here, you will see the time of your component. It seems like our is a little bit slower than this one, which is running per default. We will try to make even a faster one than this one in the Visual Studio later. But right now, you have to understand that the components which you are doing in the C# by the script editor will be always a little bit slower than those one which are taken from the ribbon or which are per default in the system. Although there is a way to run the parallel computing, because the reason why it's slower, it's mostly because it's not using parallel computing, but we'll take it in 2 days. Okay, we have make a C# script which is miming is doing the same as the series. Impressive. Let's take this code down and create train the if statement. So this I am leaving. I am opening a new one, C#, X, Y. Let's make it as 2 points, or maybe 2 spheres. Let's make 2 spheres in the Rhino. So I will make a sphere, center, radius, center, radius. So here you are taking a sphere, center, radius. I need 2 spheres because I would like to compare them, which is bigger. I hope all of you made those 2 spheres. If not, then you have a problem. But seriously, you can also use this sphere here. Maybe if you want, you can also use this too. Because the only thing which I want to have is to have one BREP here and one BREP here. And I would like to work on those BREPs now. So I will drag it here, and this one I will drag here. This X I will call B1. This one I will call B2. Type hint. This time we'll go quite advanced to the BREP. B2, we will go also quite advanced in the BREP. So if you are opening here, you have BREP B1 and BREP B2. So no matter how you call the inputs, it's also not so important if it's X or Y, you just have to be consistent during creating it. So again, where I can find the information about how the BREP is working, what are the properties, I type Rhino API BREP, and I have a BREP class. And from this one, I can take a look that I, for example, can get faces, I can get edges, I can get vertices, and also I can create much more with the methods. So what I will do now, I will just try to find the information about the volume. It will be not so easy, and let me check if oh, okay, so we can get area and get volume. So this is in the method. So in the methods, there is something like get volume. It's not a property, it's a method. So you will need, let's check. The return type, it's double. So seems to be quite easy to use. So if I will say double volume B1 equal to 0, for example, and double volume B2 equal to 0. Now, I want to use this volume B1 to be B1 get volume. I placed here empty brackets, and this is something which have to be done in any kind of the method. Properties doesn't need that. You remember when we were creating a point, I just type p equal dot x, and this was enough because this was a property. When it comes to the methods, you always need some inputs or I would say constructor to run it. So I will go again and sorry for this, and I see that get volume fortunately has brackets, but they are empty inside. I don't need any input. Although there is a version of the constructor get volume with two doubles, relative tolerance and absolute tolerance. So here you have even some tolerances to calculate the area and volume. So you could use also this one, but we will use the basic one, get volume. I will do the same to calculate the volume B2, B2 get volume. Now A is equal to, or I will say like this. There is, let's make a list of double with volumes, new list, volumes, add volumes, add volume B2 A equal to volumes, and let's run this script, or I will leave it. Just check what is inside. Okay, so we have two volumes, we have two spheres, two spheres, and we want to generally compare them. So we want to create an if statement, and let's say B, I have to add a new outcome, and this B will be which volume is bigger, first or the second one. So I will make a B. Now I had to restart com outside and inside to just have a reference object B to which I will be able to make a result. So outputs, variables. And here we will make if, sorry, we will make if, sorry, Sorry. I will make something to make it cleaner a little bit. Okay. I will call result equal to I will just write down which is bigger, and the B will be equal to result. Okay, so when I am running it, I should have the outcome from the B, which says to me that the code doesn't know which is bigger. We will try to make an if statement, which will be categorizing if the first one or the second ball is bigger. So if volume B1 is bigger than volume B2, capital brackets, then result should change to B1 is bigger. So we have the information if the volume B1 is bigger. Let's try if it's working. Since B1 is bigger, it's working. But if both of them are equal, the algorithm still don't know what's going on. So what I have to do is I have to create an alternative else if, which will be saying if volume B1 is equal to volume B2, here's more bug. Result, they are the same. And lastly, what will happen in any other case? And we know that the alternative can be just, we are missing one alternative, which is that volume B2 will be bigger than volume B1. So we can just make else. In any other case, it means that result B2 is bigger. Okay, we have some code. I hope, let me check, this is the whole code. Not difficult, but still it's working kind of the well. Okay, let's check if it's working. So I will take it out. B1 is bigger. Now I will just make a new one, very small, and I will set one rep here. And now B2 is bigger. So this one is bigger. Yeah. Now, what I have to do to make a bigger one going through this algorithm, which is checking. So I would like to have a C, which is taking bigger from these two, and it will be sorting those two numbers. So I have to create a brep as a variable, brep, which we will call bigger one. Well, or just we can leave it like this. Since we will assign to, let's check if it will work. Yeah, he's just saying that the bigger one is never used, but we declare it. And bigger one, we will say that C is equal to bigger one. And now since we have the whole algorithm working, we just have to place bigger one assigning in the correct place. So if volume B1 is bigger, this is happening here, bigger one equal to B1. If they are the same, then let's say that bigger one, no matter which it will be B1 again. And in the last case, if we want to have B2, B2 is bigger, then bigger one, it's B2. Let's run it. And see if it's working. So brep. So this is definitely bigger. So it's highlighting. So so it is working. If I will create a new one, or we can make it here in the Grasshopper. Let's make a sphere. Two spheres to be just sure. And then from 2 to 20. Since they are overwriting each other, I will just quickly create XYZ point. You don't have to follow me here, because, or you can if you want. Okay, so I have two spheres. I can control now which one is bigger, which is not. I will turn off the preview of it. And now this is bigger. Now this is bigger. If this is bigger, this is jumping here. So the C# script with the if statement, it's working. I will just copy it to the mural. All of you will be able to check it, and we'll make a short break, like 5 minutes till 40, and we will come back with the last part of today's workshop. Okay, I think we will continue last 20 minutes or 15 minutes even. Whew. And what I was just checking what I planned for today. I think we are on the right track to finish that part. We should have some, at least some sorting of the lists. So let's try to make this one. I think I will skip the tree operation on the C#, but you can link to this YouTube movie. It's explained there. So let's go for it. I will now turn off the preview and let's go for the last, or maybe not last, but we will see. C# script. And now let's make a loop in a loop. So we would like to create a series or the basic grid of the points in a simple way. So exactly like how we were using the the grafting to create a population of the points, we will try now to create the grid of the points in the C#. So first of all, what we will need, it's the list of points. So this will be our list point 3D equal to new list 3D. I'll just type here. Plus. We have variables, and let's. I will create a nicer code of the of it. So I will call it output points. So all points, and say that outputs all points equal to points. So all points, 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 points. Objects X and Y. Let's do not touch this at the moment. We will just try to create it internally. So do you remember how we were creating a point? Point 3D, PT equal to new point 3D. And here we have to specify the coordinates. I will save it as 0, 0, 0 now. And I will create our operation on the list. So first loop for integer I equal to 0, I lower than 10, I plus plus. So we have a first for loop, and let's say that points add pt. So in each of the iteration of our for loop, we will be adding 1 point to our points list. It should be possible to see it already. I will run it. All of those points have exactly the same coordinates, so they are overwriting their position. So if I go for the panel, I should have here 10 points with the same coordinates. Now, what will happen if I would like to have a grid of points, for example, 10 by 10? I can, of course, create a loop with the for statement from I equal to 100, but it will be problematic. So, because I will lose the control about which points are in the points and which are in the rows. So in the columns and in the rows of this, let's say, the grid position. So I will create a second loop for integer j equal to 0, j smaller than 10, j plus plus. And I will move these points here inside this internal loop. If I will run it, I will have now 100 points, which are generally overwriting each other, so they are presented in Rhino as a single point. Let's try to make it a little bit nicer. So let's try to move generation of this point inside here, inside the loop. If I will run it, it should not affect at all. But now I will be able to change those coordinates. So if I will type here sorry, I will run it. I see that I created 10 points. And then if I will type here J, I will run it. Per definition, you know that I was using before the convert, but it was the integer will in some points can be changed automatically into the double. But of course, per definition, you should use the convert. But here we'll don't care about this. We will just create it as it is. So a and j will stay as an integers. It's internally changed to double. So I have my grid of points. Now I would like to control the number of the divisions and the steps. So I will introduce some inputs. First will be span x, span y, columns, I will say cols x. Those two will be integers. So integer, integer. Those two I want to be double. So I have this should be a span. This should be the number of the columns in the x and y direction. Let's make some numbers here. Let's make it from 5 to 9. Sorry. And I will make it like 0.5 for the span. Okay, right now it's not working, but soon it will start. Okay, I go inside and checking here. Span x is a double, span y it's double, cols x it's integer, cols y it's integer. So those two we can generally easily say we want it to be here. I should be smaller than number of the columns in the x direction when j we want to be smaller than the y. If I will run it now, I should be able to control a number of the divisions in two directions. So this is y direction and this is x direction. Now I want to use also the span to distinguish the distance between the columns in the x and y direction. I will go inside and I have to declare sx, which will be span x equal to 0, double sy equal to 0. Okay, so now x sx, since we want to start it from 0, then it is not a big deal. Sx should be I multiply by span x, sy equal to j multiplied by span. Let's see if it will work, or we have to convert. It worked. Let's see, like it didn't make any error, so we don't have to convert a and j. It's automatically changed to double. So we will stay with this, and here we will place the sx, and here we will introduce sy. Let's change, let's see, columns x, it's working, columns y, it's working. So so this is I can call also this one as the C# script read maker. And maybe since we have still, I will give you this code, since we have still some time to make it. No. I see you are working, because when I paste this code, at least somebody's taking it from URL. Okay, so this is kind of the classic thing. If somebody has anyway an error or would like to have assistance with his, then he should just let me know in comments. I will just make also a print screen to make it clean. This code, it's running to this part. Okay. So last thing what I would like to, how I would like to, or what I would like to do, it's that generally I would like to create those points also in the Z direction. Let's try maybe to do it. So I don't know if we have time for it, but we can at least try. If no, then we will continue tomorrow. Did I copy? Because I don't. Okay, I want to make a copy of this. Turn it off, and I will be working on this one. Grid maker, and let's go for the last object. So for integer k, so, I will zoom in. Sorry, k equal to 0, k lower than 4, for example, k plus plus. I'm moving it here. And I will place k here just for the try. So we see that generally we created it, but we would like to have a list of levels which we are taking, and he is populating those points on the specific levels. So I will go here and call it levels. And this time I will use double. And important thing, here I'm clicking on the list access. And most of you should now look on my screen and take a look. Here I am changing it to the list access. Now, if I will go inside, I see that I have list double levels. So the script editor knows that I am giving him a list as an input. So if I want to work on the levels on the list and apply some specific height z coordinate here, I will create a double on the beginning z level equal to 0, and on the beginning of the code inside the loop I will say z level it's equal to levels from k. So if you want to come to the specific item in the list, you have to use rectangular brackets. Rectangular brackets are allowing you to take the item from the list. So here instead of k, I want to use z level now, because this will be the level from my levels list. I just need to create it. So I am opening the panel. I want those grid of points on the level of 0, on the level of 3, on the level of 6, and the level of 12, for example. Let's make it like this. Let's make a multi-line data. This is a list of doubles. So I'm connecting it here, and I have my list of doubles. Now, if I will go for the 5 positions, here I have I don't remember how it was. I think we had 8 meters in the building, 6 columns. Here we got 5. Here we got the 4, I suppose. So I make a little bit too small slider. So I will go from 3 to 7. And this is something which we got. So list of levels. Okay, so we have 2 minutes to come to the end. I hope I will just give you this code also. It's not very difficult, but more difficult than the one previously made. But okay, so at least you see how much faster it was to make compared this one with the spaghetti which we made before to produce those grid of the points in the Grasshopper. It's kind of easy also to come from this point till the lines and polylines, but we will leave it like it is. If you have any question, comments, and you want me to show you something, I could in general try to show you how the Galapagos is working even on this if you really want, because we can try to make just to make a preview. We have a bounding box, so this is something which is generally creating let me check. I will just create. Um, I have some numbers of the spheres. So I have 96 spheres here with the wait, sorry, I lost the screen. So we have this one, and now we can generally try to make also a B-rep. Let's make it with the bounding box. And there is something on the beginning in the params. You have something which is called a gene pool. It's here. So it's here, params gene pool. And let's say that I would like to have 96 sliders. These are like a list of sliders. So it's nothing if I could manually create 96 sliders and put them together, but this is generally like 96 sliders. If I will combine it here, I will just make it a little bit smaller. Minimum should be maybe 3. Maximum should be 6. Decimals, let's make it 1. I can randomize it. So I have I will randomize it 100%. So each one of them, it's a little bit different. And now we can use this gene pool to, for example, randomize those spheres to create the biggest volume in all of the spheres. So obviously, if we will make them as big as possible, we will have the maximum. But let's make it simple to make. So volume. And let's make mass addition, which will generally create a single number. So he will just add all of those numbers to each other. And we will need also to declare it as one single number. So this is volume of all objects. And now the only thing which we have to do is to grab Galapagos, take the fitness as our volume. So I'm dragging it here. The genome should be this gene pool. So he will try to move those sliders in such way to produce this minimum or maximum. It's obviously that we can just put it here a maximum and it will create the maximum, but let's make it work for the genetic algorithm. So we are maximizing here, go for the solver. I'm clicking here to be able to see it. And he starts to move. You see here, he is moving them. So he is creating a population of the results. Soon you will see how it is converging to some values. Yeah, I'm not sure why it's so slow. It should be a little bit faster, but Yeah, so I am waiting till he will finish the first population, and then I will just stop it. But this is how the Galapagos is working. So if we have some criteria, boundary criteria, and we have some rule, we can generally move those sliders to find some optimum value, maximum or minimal value. But you have to understand that the Galapagos, it's not it's the multi-objective optimization, so it doesn't have to find the minimum and maximum. It will just find the population of the results. So I see that he got a 50 population. Initial boost was 2, so he has to create 100 variants to go into the next stage. Yeah. So this is the population. I will stop the solver now. With every population calculated, he will be a little bit easier. But for example, the volume which he found as a quite big one, it's when the sliders are in this position. So if you want to see, if you want to see different solutions which he found, you can generally grab here. So this number 4511, it's generally this one. So you can go into a solution which was not maybe the best one and reinstate this solution. So it gives you this 37946 volume. With every iteration, probably it will come to bigger and bigger volume, and finally you will figure it out that all the sliders should be maximum to the right. So yeah, that's very simple software. It's nothing to be afraid of. Okay, we are starting tomorrow from 9. Bunji will present it for you. Some basics of the C# or more advanced than today, but still quite basic. Thank you for today. If you have any comments, thoughts, and some dilemmas of your life, you can always call me or put it on the chat. I will answer on all your concerns. See ya.